The universe is vast, and when we look up, we wonder it's out there somewhere in the universe.
There's a world similar to ours, another intelligent life form also looking up and asking the same question.
Or is Earth the only place with life? And recently, some missions from NASA have discovered that there may be far fewer galaxies than initially predicted.
This increases the possibility that humanity is alone in the universe.
The New Horizons mission brought the first close-up images of Pluto, providing enough data for scientists to conclude that the number of galaxies is likely hundreds of billions,
instead of 2 trillion as initially estimated. Astronomers can estimate the total number of galaxies by counting everything visible in the heat Hubble field, and then multiplying by the total area of the sky.
But galaxies are too faint and distant to be directly detected. However, while we cannot count them, their light still fills space with a faint glow. To measure that glow, astronomical satellites must escape the inner solar system and its light pollution, caused by sunlight reflecting off dust. A team of scientists used observations from NASA's New Horizons mission to Pluto and the Kuiper Belt to determine the brightness of this cosmic optical background. Their results set an upper limit on the abundance of faint, unresolved galaxies, indicating they number only in the hundreds of billions, not 2 trillion as previously thought. Lead author, Mark Postman, ed. So how dark is space? If you get away from city lights and look up, the sky between the stars is truly dark. Above Earth's atmosphere, outer space fades into an inky blackness.
Space is not completely black because the universe is filled with a faint light from countless distant stars and galaxies. New measurements of that faint background light show that unseen galaxies are less abundant than some theoretical studies suggested, numbering only in the hundreds of billions, instead of the 2 trillion galaxies reported earlier.
Previous estimates were extrapolated from very deep sky observations by NASA's Hubble Space Telescope.
It relied on mathematical models to estimate how many galaxies are too small and faint for Hubble to see. The research team concluded that 90% of the galaxies in the universe are beyond the detection capability of Hubble and James Webb in the visible light range. The new findings, based on measurements from NASA's distant New Horizons mission, suggest a much more modest number. The cosmic optical background that the team attempted to measure is the visible light equivalent of the cosmic microwave background, the faint light after the Big Bang before stars formed. While the cosmic microwave background tells us about the first 450,000 years after the Big Bang, the cosmic optical background tells us something about the total of all stars that have formed since then. It sets a limit on the total number of galaxies that have been created and their location in time. The team could not use Hubble to make these observations. Although in space, Hubble orbits Earth and is still affected by light pollution, and space telescopes like it remain within the solar system. The inner solar system is filled with tiny dust particles from disintegrated asteroids and comets.
Sunlight reflects off these particles, creating a glow known as zodiacal light that ground-based sky observers can see.
To escape zodiacal light, the team had to use an observatory that has escaped the inner solar system.
Fortunately, the New Horizons spacecraft provided the closest images ever of Pluto and the Kuiper Belt object Arrokoth, far enough to make these measurements. Traveling at over 53,000 kilometers per hour, the $720 million New Horizons spacecraft is now at the edge of the solar system, allowing a view that is 10 times darker than Hubble's vantage point. The team analyzed existing images from the New Horizons archive. To highlight the faint background glow, they had to correct for several other factors. The most challenging correction was removing light from Milky Way stars reflected by interstellar dust. The remaining signal, though extremely faint, could still be measured. So, what is the origin of this residual light?
There could be many dwarf galaxies in a relatively nearby universe, beyond detection, or the diffuse halos of stars surrounding galaxies could be brighter than expected.
There could be a population of rogue stars, scattered between galaxies throughout the universe. There could be more faint, distant galaxies than theory suggests. This means the true distribution of galaxy sizes measured so far would exceed the faintest observable systems we can detect. The James Webb Space Telescope is expected to help solve the mystery, but it is limited by dust in the solar system. If individual faint galaxies are the cause, then Webb's ultra-deep observations should be able to detect them.
A smaller number of galaxies increases the possibility that we are alone in the universe, as calculations show that life in the universe is extremely rare and the chance of civilizations existing is even more remote.
In 1961, astronomer Frank Drake formulated an equation to predict how many planets in our galaxy might have civilizations.
This formula is called the Drake equation, and when he under considered factors like the number of stars, the percentage likely to have planets orbiting them, the percentage likely to have life on those planets,
he concluded that the universe must be teeming with sentient beings. But where are they? We haven't heard from them since Drake and colleagues searched for extraterrestrial civilizations. According to Dr. Andrew Watson, a climate scientist at the University of East Anglia, UK, the likelihood of finding extraterrestrial life similar to us is extremely, extremely low.
Perhaps only 0.01% over 4 billion years would produce a planet like Mars capable of supporting life.
In this, Dr. Andrew Watson argues that our planet is an extremely unusual case, not only because it has liquid water, is the right size to hold an atmosphere, but also because it has a giant neighbor, Jupiter, which helps deflect asteroids and small debris.
Otherwise, they could have shattered Earth during the formation of the solar system.
Or there could be countless special planets like Earth, with advanced civilizations somewhere out there.
But because the distance is too far, the signal cannot yet reach Earth. Currently, our technology is still limited in searching for and communicating with extraterrestrial civilizations. The ability to receive signals from distant planets is very weak and can only detect strong signals.
Therefore, it is very likely that advanced civilizations exist out there, but their signals are too weak for us to receive.
Subscribe to the Guian Ego channels.